All right, let's take a look at processing nuclear. So first it starts with a little isotope practice. So to write the isotope symbol for an atom that has 16 protons and 16 neutrons, we've got to go over and look up what number 16 is. Number 16 is sulfur. So we want to do an S for sulfur, and then the lower left is the atomic number, the number of protons, and the upper left is the mass number. So we get that by doing 16 protons plus 16 neutrons. Next it says, write out the isotope symbol for an atom of nickel with a mass of 60. And I knew nickel was Ni, which is helpful. There it is on the periodic table. It's number 28. What do nuclear fission, fusion, and radioactive decay all have in common? They all release a lot of energy. Maybe I should just say they all release energy, because radioactive decay, I guess, doesn't always release a lot. What's the difference between nuclear fission and nuclear fusion? So nuclear fission is the splitting of an atomic nucleus, while nuclear fusion is the joining of two atomic nuclei. So in other words, nuclear fission is one thing splitting up into two smaller things, and nuclear fusion is essentially the opposite. It's two smaller things joining together to form one bigger thing. The sign doesn't look right. There. What's the difference between these two types of radioactive decay, alpha and beta decay? Let's type this out. In alpha decay, a nucleus loses part of itself, and the part that falls off, that chunks off, is the size of a helium atom without electrons. So 2 protons plus 2 neutrons. This means the original nucleus will decrease by 4 in mass, and it won't be the same atom, same type of element anymore, because it now has 2 less protons, so the identity changes. In beta decay, a nucleus loses a high energy beta particle, and this causes the nucleus, and this process turns a neutron into a proton. So the mass number doesn't change, but the identity of the element atom does, because the atomic number goes up by 1. So these are both changing the type of atom. We lost something here. There we go. Fill in the blanks of the following nuclear reactions and label each as either alpha or beta decay. Well, this is kind of the symbol that goes with beta decay. And we know the mass doesn't change, so it's still going to be 187 on the top. Since the atomic number goes up by 1, it must have been 75 before. And then I need to look up number 75. It's Re. So Re goes here. That's a beta decay that just happened. This one, I see the size of a helium nucleus chunking off. So this is alpha decay, and I want to do some subtraction here. 256 minus 4 is 252. 103 minus 2 is 101, and element 101 is MD. Okay, a little more practice here. Writing out the whole nuclear reaction. Francium 221, it's number 87, undergoes alpha decay. Well, it's going to lose something the size of a helium atom. Sometimes you'll also see it as an alpha like this. Okay, it doesn't matter, it's the equivalent. And we need to subtract 221 minus 4. It's going to go down to 217 for its mass. And 87 minus 2, it's going to go down to 85 for its atomic number. And 85 is element At. Thorium 234, it's number 90, emits a beta particle. So a couple ways we can do it. We can do it E like this, or we can draw like the beta. And the 90 is going to go up to a 91, and the mass is going to stay the same. So then we've got to look up number 91, that's PA. And then this last one, plutonium, which is number 94, 238, fuses with helium. Notice the plus sign is to the left of the arrow in a fusion. And we're going to make 242, and now we're going to be element 96. So we got to look up 96, that's curium. And so that's CM, was it? Yeah, that's right. And the last question here. What are 2 benefits and 2 hazards of nuclear chemistry? So I would say there's lots of options here. Answers vary. Some may include benefits, nuclear power, it's clean energy, and then maybe a hazard. Same thing, nuclear power, radioactive waste. And I guess maybe I should clarify, it's clean energy. It doesn't release carbon dioxide into the atmosphere like burning coal or natural gas does. Nuclear medicine. Yeah, can be used to kill cancerous cells. A hazard of nuclear medicine, it often kills healthy cells too in the process, which can produce some really unpleasant side effects. And again, there's more things you could go into here, but I'm just going to stop there so you have a couple examples. All right, there you go.